Okay, so for 47.1, we're going to talk about the nature of bonding and structures of some of the elements across the period. So the period that we're focusing will be period 2 and period 3. That means from lithium all the way to argon. So before we talk about the periodicities, okay, first of all, we'll just have a recap on the periodic table. So you can refer to page 3. Okay, so you have to remember that, okay, the elements are arranged in the order of increasing atomic number. Remember, we're talking about the atomic number, okay? All the times, sometimes you'll find that, okay, they will say our relative atomic mass. So do remember in the MC, if you say that, oh, they are arranged in order of increasing relative atomic mass, that is wrong, because you may find that some of the relative atomic mass of the elements in the periodic table, they are very similar, or they may be smaller on the left hand side than the right hand side. So therefore, the correct answer for this one should be talking about atomic number. Other than that, the elements are also put in the group and periods. So you have to remember, for the group and periods, group referring to the number of outermost shell electrons. Okay, so for group 1, okay, they will have one outermost shell electron. Group 2, they have two number of outermost shell electron. But for the period, okay, we're referring to the number of occupied electron shell. So do remember the keyword goes to occupied. Okay, so after we know how the elements are arranged in the periodic table, now we move on to the terms periodicity. You may not find this word in the textbook, okay, but periodicity, okay, is something that we represent referring to the recurring trends. That means they will just show up again and again. Recurring trends that are seen in the element properties. So for the elements, they will have some properties that they will repeatedly showing up in the period. That means like this. Okay, you can refer to this table again. So take a look of the color. So you have the blue one represent metal, green one represents semi-metal, and then the yellow one represents non-metal. So in this case, you'll find that they have metal, semi-metal, and then non-metal. So you can see that, okay, from period 2, they will be metal, semi-metal, non-metal. And after they go to this third period, they will be again metal, semi-metal, and non-metal. So this one will keep on going, metal, semi-metal, and non-metal. So this one, okay, we will talk about the period. We will just describe this as part of the periodicity of the elements. Okay, so for periodic variation, you can refer to page 5. In these sections, we're going to talk about two of them. The first one, okay, we talk about the nature of bonding. So for the nature of bonding, you can have a look of the first period 2 elements. Okay, so you find that they will have mainly, okay, for lithium and beryllium, they will have metallic bond because these two are the metal. Okay, and then after that, we'll move to the non-metal section. So this one, these are the non-metal. But if you remember, okay, for B and C, okay, boron and carbon, for carbon, you must know that, okay, they are part of there are elements that have a special structure that is called giant covalent structures. So actually same as boron, okay, both of them, okay, they have giant covalent structures. So for the nature of the bonding, they will change from metallic and then they will go to covalent. Okay, so because they are in giant covalent structures, so therefore you will find that, okay, they only contain covalent bond. But after that, okay, when we go to nitrogen, oxygen, fluorine, and then neon, we will find that all these things, okay, they are no longer having giant covalent structures. Instead, they are having simple molecular structure. And for the simple molecular structures, okay, you will find that between the molecules, okay, they will have the van der Waals forces, while within the molecule will have covalent bond. So for these, okay, you will find that for nitrogen to neon, they will have covalent bond, okay, the attractive force between the nuclei and shared electrons. What means by that? Nuclei are the positive one, okay, and the shared electron is a negative one. So the attraction is talking about this between the nuclei and the negative electrons. And other than that, okay, between the molecules, you will also have van der Waals force between the molecules. Okay, so these are the properties of the nature of bondings, and you will find that in the process they will change from metallic to covalent, pure covalent, and then afterward they will have covalent mixed with van der Waals force. After that, when they move on the third period, they will go again from metallic, covalent, and covalent mixed with van der Waals force. So this is called the periodic variation. Other than the nature of electron, okay, just now actually we have mentioned, we're talking about the structure okay, of these elements. So the one on the left hand side will have giant metallic structure. So you can see that we have giant, so we'll have giant metallic structure, and the metallic structure is talking about the cation and also the delocalized electrons. Okay, if we draw that again, you'll find that they have cation, and then we'll have delocalized electrons in between. So these are the attractions between metal ions and delocalized electrons. And after that, okay, after from GMS, okay, we will go to GCS, giant covalent structures. So you find that, okay, the atoms, they are linked together in a three-dimensional structures. So this one, do you need to draw? I don't think so. Okay, but for the diamond and also graphite, okay, remember you have to sketch, okay, the three-dimensional structures of it. Okay, for diamond, okay, remember you have the chicken feet, okay, and then 3 stroke going down. Okay, you got an M, you got V, and then your last stroke. So every connections, okay, you're going to draw a atoms there. So this one is how you draw the how you draw a diamond structures. Okay, so the other one will be the graphite. So you need to draw the hexagonal layer, okay, and then draw some atoms right there. So one carbon is connected with 3 other carbon. This one is 1 carbon connected to 4 other carbon tetrahedrally, if you remember the terms. Okay, so this one, okay, they are connected, okay, in the planar structures, and then you have van der Waals force in between. Okay, you draw another hexagonal structures there. Okay, so this is the structures that you have to learn how to draw. Okay, this one is a little bit small. Okay, this layer is a little bit small, so you better draw it bigger for that. Okay, anyway, so remember you have to draw diamond and graphite for that. Okay, while for the nitrogen, oxygen, fluorine, and neon, okay, mentioned before, okay, they are having simple molecular structure. So from giant metallic structure, go to giant covalent structure, and then go to simple molecular structures. So the nature of bonding and structure, they are some kind of property that they will periodic, they will have a periodicity, they will recurring again and again. So pay attention for the size of the molecule. So we have like nitrogen, oxygen, fluorine, and also we have neon. Okay, so for the size of that, you'll find that the nitrogen, oxygen, fluorine, they're quite similar to each other, but neon, they just have 1 atom, so therefore they will relatively smaller than the other 3 of them. Okay, so now we move on to periodicity. Something very similar happened. So you'll find that they are the first 3, they were giant metallic structure. They are holding between the delocalized electrons and also metal ion. And then silicon are the giant covalent structure. Okay, the one that we learned is silicon dioxide, but actually silicon itself, it can also form a giant network. Okay, very similar to a graphite. You can see, very similar to a diamond. You can see that. Okay, and then the last one, okay, will be the simple molecular structure. So for P, S, Cl, and Ar, they are also having simple molecular structures. And for the nature of bonding, again, they will be having metallic bond. They will have go to purely covalent bond, and then covalent bond mixed with van der Waals forces. Okay, so do remember, okay, make use of the time, okay, to remember what are the particles between these attractions. So for metallic, they are between the metal ions and the delocalized electrons, while the covalent, okay, they are talking about the nuclei and also the shared electrons, okay, the nuclei and shared electrons, while the van der Waals force, they are between the molecules. Okay, so just want to draw your attention, this one is very, very, very important. That will be these four pictures. So you find that this time they are not diatomic molecule. Instead, each of them they will be slightly different from one another. So for P, in order to make it stable, you will find that they will be in the format of P4 structure. P4 structure. While the sulfur they are in a crown structures. Okay, just like a crown. Okay. Just like a crown, okay? So this one actually is like this, okay? So they have a crown structure. So that is S8, okay? Now just 2W, put it together, and then every part, okay, you just add a ball at the end. While the other one is a pyramid, okay? So you have a pyramid. So you just draw atoms at the four corner will do. So the last one is Cl2 and Ar. So right here you can see that okay, their molecular size will be different from the others. If you remember, when the Weyl force, the strength of when the Weyl force will be depends on the size of the molecule. So from here you can see that okay, actually S8 is larger than P4 and larger than Cl2 and larger than Ar. So the sequence okay will be S8 larger than P4 and larger than Cl2 and larger than Ar. You may say that okay, Ar have a relative higher atomic mass than Cl, than S and 8 than P, but you have to find that okay, the number of atoms inside the molecules are different. So S8 is much higher than that of P4 and Cl2 and Ar. Okay, so this sequence is absolutely the most important part that you have to remember. Okay, and also how to draw this molecule as well. So again, giant metallic structure, giant covalent structure, simple molecular structure. This is the nature of the other structures okay, of these particles. So you can have a look of the class practice, okay, 47.2, okay, so we'll just have a idea, okay, how the question will be asked. So write the chemical formula of the molecules in the elementals, phosphorus, sulfur, and chlorine, the chemical formula for the molecules. So again, P4, S8 and also Cl2. Okay, name the chemical bonding hold the atoms together in the above element because they are molecules, so you know that that will be covalent bond. Okay, and the last one, C, arrange ascending order. That means from small to large, so must be 2 atoms molecule, diatomic molecules. It go to 4 and it go to 8. So last one, attractive force holding the molecule together, that will be van der Waals forces. So actually this chapter is pretty easy, okay, if you know the concept well. Okay, so conclusion, okay, you have to remember elements are arranged in the order of increasing atomic number, not relative atomic mass. Okay, even though they look like to be, but actually they are not. Okay, so they are put into they are put according to group and also period. Okay, one will be related to the number of outermost shell, one will be related to the number of occupied electron shells. Okay, occupied electron shell. Okay, and also periodicity is not found in your textbook. Okay, but they are talking about the recurring trend. That means they will occur again and again and again. So we'll talk about the nature of bonding and also structures. Also, okay, the nature of bonding, you will find that they will change from metallic to covalent. Okay, they will change from metal, semi-metal, and then they go to non-metal. So we also have one description for that. We'll say that the metallic character of the elements, they were going down. Okay, sorry, this one I forgot to mention just now. Okay, remember when we go from left to right across the period, we find that the metallic character of the elements is going down, decreasing, okay, from metal to non-metal. Okay, while the structures of them, they will be giant metallic structure, giant covalent structures, and finally go to simple molecular structures again. And then when they go to the second period, they will start from giant metallic structure again. So for the molecular size, okay, we'll focus for these four of them, which are P4, S8, Cl2, and Ar. Okay, several structures, okay, remember the sketching of them are important as well, like graphite, like diamond, and also some of the molecules just I mentioned. Okay, so that's all for this video. Bye bye.